All right. 3.4 velocity and other rates of change. My goal is to get the rest of this chapter, and I think it's just 2 more sections. I should probably check that. I don't remember. Yeah, just 2 more sections before Thanksgiving, so that way we can get a test in before Thanksgiving is my plan. The earliest would be Friday, but it honestly probably will be like either the Monday or Tuesday after. I'm going to try not to do it the same day as whatever physics would be.
Didn't even take my long
Yes.
Is that asking if I'm taking you?
Why is it blue?
Yes, so thank you. I forgot that was up there already. Literally just yes, because you have to go online and say one way or the other if you're going to take it or not on the thing, and you have to do it. Like, we can't do it for you. Yours is listed as undecided. So if you can go on and fix it one way or the other. You can choose to do it after Monday, but if you don't do it by Monday, then you have to pay an extra $40 if you decide you want to take it. So, Melcher, are you taking both AP tests? Okay. I was making sure. Yours was listed as taking it, but I wanted to verify because I'm like, when people signed up for the class, they might have accidentally hit, so I'm trying to like ask everybody, but Miss Holloway specifically asked me to ask the people whose names are on the board, so okay. Let's see. All right. Instantaneous rate of change. Of f with respect to x at a is the derivative f prime of a is equal to the limit as h approaches 0 f of a plus h minus f of a all over h. Okay, so it's the same thing that we looked at in like section 1, I think it was. It's the same like formula, whatever, I don't know, however you want to say it. Provided that the limit exists. Welcome.
I'm late like I was like every day last year. I'm really ready to survive. Hang on. You don't have to last Friday? I'm not.
All right, so let's see. Find the rate of change of an area A of circle with respect to radius r. So the formula for area of a circle in general is A is equal to pi r squared. So when I'm asking for rate of change for something like this, it's basically just wanting me to take the derivative of the function with respect to whatever variable it says. So in this case, with respect to r. So all I would need to do is dA dr is equal to 2 pi r. And that's all you have to do for that. And then the question would say something like, evaluate the rate of change of A at r is equal to 5 and r is equal to 10. So basically all you're doing is putting in 5 or 10 for r. So 2 pi times 5, which is just 10 pi, and 2 pi times 10, which is just 20 pi. So that would be at those particular points. So when you think like rate of change for something like this, you're thinking take the derivative.
I'm going to remove colors.
Sounds good. And then something else that I would ask you is like if r is measured in inches. And A is measured in square inches. What units would we have for DADR? So basically that would look like square inches per inch. Okay, meaning something like this, which would just be equal to inches. So that would be the answer to that particular question if that was asked.
I got to the buck yesterday.
Nice. I almost got one with my car last night.
Oh, that's not nice.
It was a fat one too. Thing was huge.
There was like an 8-pointer in our backyard this morning. It was huge. You got a 6.
I haven't even gone this year. I honestly haven't even thought about it until literally yesterday.
That was the second time. I think you went. He doesn't do it. I don't know. His brother might do it. I'm not really sure.
We do it ourselves.
I don't know. When he got the one last year, there was like he went with some guy and like they had like a processing thing there, so they could just like left it there. That was in like Alpine and stuff. I don't know where. It was. I don't know. Where it was. But anyway, it's time to eat it. I'll tell you that.
I know. I need to go just so I can get meat.
To eat it.
Because Kenny's dad just gives all the meat away now to whoever comes to clean it. And I'm like,
No, I want to eat it.
yeah. He just doesn't care. He just wants them gone because they eat all of our food.
So bad.
All right. Motion along a line. So this is going to start to look, well, if it hasn't already, it's going to start to look a lot like physics. So position S with t as a function of time. And displacement over a time interval. T to t plus delta t. Okay, delta t is just like in this case, just like a small little change in time. So like adding like increments of time to it. We would have delta s is equal to, so change of position essentially is equal to f of t plus delta t minus f of t. And so we would have average velocity, which is displacement divided by time, is equal to delta S over delta T, which is F of T plus delta T minus F of T all over T. So outside of the way that we did it in physics, you can do it this way using calculus. Then instantaneous velocity is the derivative of the position function S is equal to f of t with respect to time so v of t is equal to ds dt, which is equal to the limit as t or delta t approaches 0 of f of t plus delta t minus f of t all over delta t. Okay, so literally all this is saying essentially is whatever your position function is equal to, take the derivative of it and you get your velocity function. And, well, I won't steal the thunder away, but you keep going and you can get to acceleration as well. But we'll get there in just a second. Let's see. Speed is the absolute value of velocity. Okay, because remember, speed doesn't have a direction, but velocity does. That's why that's the case. Obviously, that's more of something you learned in physics, but so speed is equal to the absolute value of v of t, which is equal to the absolute value of ds dt. I thought you did that because I did that to my shoulder. Or was
I was like, what?
Oh. I did that and then I heard her do that. I was like, All right, and then acceleration is the derivative of velocity with respect to time. So a of t is equal to dv dt, which is equal to the second derivative, okay, of position. So that's how we write the second derivative there, is the d2s over dt2. All right, so then obviously in physics, okay, we've talked about the gravitational acceleration, K is 9.81 meters per second squared. A lot of times this book is actually going to do everything in English units instead of metric units. So I'm going to show you what that would be here as well. What?
I just looked at the picture you sent me. That's funny.
All right, so free fall constants, K for Earth, K if you need something different, your book will tell you what it is. But our English units, G is equal to 32 feet per second squared. And we would have S is equal to 1/2 times 32 t squared, or 16 t squared would be our position function that we're working with. Okay, S is in feet in this particular case for position. And then if we went to metric, like we would in physics, G is equal to 9.81 meters per second squared. S is equal to 1/2 times 9.81 times t squared, which is just going to give us, the book's going to say 4.9 t squared with S in meters for this one. All right, in this section, a lot of questions are going to have multiple parts. You're going to see like an A, B, C, and D for these ones. So we're going to look at number 2. Okay, it says, well, it's in 4 parts, but write the area of a circle as a function of the circumference. Okay, so I like to start out with just like some information that we know before we jump right into the question. So what is the area of a circle? Okay, so area is pi r squared. What about circumference?
Is this all in one
Half.
Do you know, Sarah? No. 2 pi r is circumference. Okay, so what variable do both of those have in common?
R.
Okay, they both have r. So I want area as a function of circumference. So that means that I need to have circumference being my variable. So I need to solve both for r, okay, and replace, I don't need to solve both for r technically. I need to solve I need to solve circumference for r, and then I'm going to plug that in the other equation. So circumference for r would give me r is equal to c over 2 pi. So then when part A says to write the area of a circle as a function of the circumference, I would have area is equal to pi times, I'm going to replace r with this c over 2 pi and square it. So then it's going to give me area is equal to pi times c squared over 4 pi squared. Okay, and then I can simplify that down to A is equal to 1 pi is going to cancel, so c squared over 4 pi. And so that would be area as a function of circumference. So then, just to make your life easier for the for following stuff, sometimes it can also be nice to write this as like 1 over 4 pi times c squared, because when in a minute we're going to have to take the derivative of it. That way it's just already nicely laid out for you. You don't have to rewrite it that way, but sometimes it just helps to see it. Because part B says, find the instantaneous rate of change of the area A with respect to the circumference C. So that wants me to find dA dC. So what is the derivative of this then? Yeah, the derivative of this.
Oh, that'd just be 2c over 1. Yeah. Just 2c.
Well, it was over 4 pi.
4, yeah.
So 2c over 4 pi, which is going to simplify down to...
It's 4 pi. 4 pi's not a variable.
Check the
I don't know,
log.
Melcher, is pi a variable?
I don't think it is.
What is pi equal to? Can pi ever be anything other than 3.14159 and so on?
No.
So pi isn't a variable.
Oh, I have no knowledge for you.
So that's equal to c over 2 pi.
So then, how do you take the derivative
Can I
of
go
pi?
back to the cars?
Just like you would a constant, yes.
So it's 0?
You're not taking the derivative of that because you have a variable with it. You just throw the power out front, which you did. So you have 2 over 4 pi times c, because you subtracted 1 from the exponent. Then you just simplify it. Pi's a number, right?
Yeah.
So I treat it just like I would the number 4 or the number 10 or the number 1,000,000.
Okay.
Got it now, or are you still confused? Okay, part C then. Evaluate the rate of change of A at C is equal to pi and C is equal to 6 pi. So C is equal to pi and C is equal to 6 pi. So I'm going to take this and just plug these in for that. So pi over 2 pi is equal to 1 over 2. And 6 pi over 2 pi is equal to 3. And then D, the last part of this question says, if C is measured in inches and A is measured in square inches, what units would be appropriate for dA dC? So dA over dC is equal to inches squared over inches, which would just simplify down to inches. Alright, this next one's going to be a little harder just because it's something that we're not as familiar with probably. Number 4. So a square of side length S is inscribed in a circle of radius R. So
Sorry, my bad.
I was like, what is
No,
that?
I opened my Instagram and I was about to do this.
Alright, so I have a square inscribed in a circle.
Define the area
Close enough.
of the circle. It's not inside of the square.
Okay, so it's got radius R. So to get from here, this is gonna irritate me because I want it to. Okay, there we go. So to get from here to here, okay, this is 2R because we know that from there to there, that's just R. Okay, that's the radius. It's got side length S, so all my sides are length S, not 5. They kind of look like 5s, but they're S's. So then the part A wants us to write the area of the square as a function of the radius r of the circle. Okay, so just in general, start with this. What is the area of a square?
Side times side.
Okay, side squared. And the area of a circle? Pi r squared. So, well, right now I'm just getting information down that I know. That'll help me get to where I want to be, ultimately. So now, would you agree that I have a right triangle right here?
Yeah.
Okay, so I've got a right triangle there. So I could say that just based on the fact this is 1, 1, okay, these are both 1s, then this right here, okay, would be the sine of 45. Special triangle. Can we agree with that?
Triangle does.
Okay, so I've got the sine of 45, because this is clearly splitting this in half, right?
Yeah.
Because it's a square, is equal to opposite over hypotenuse, so s over 2r. I need to get, what?
Sine of 45
Um,
Oh, no, it's not.
well, we're going to get there eventually. So, sine of 45. So I need s by itself, so I'm going to have s is equal to 2r times the sine of 45. Now what I'm going to do is I'm plugging this in for s right there. So I'm going to have area is equal to 2r sine of 45 squared. So the sine of 45 is what?
Square root of 2 divided by 2.
Yep, square root of 2 over 2. So I can rewrite this as 2r root 2 over 2. And then I'm squaring the whole thing. Okay, you can either go ahead and cancel your 2's now, or you can wait until after you've squared it, but I would just go ahead and cancel them since everything's inside. So that leaves me with squaring the r and the square root of 2. So that means that I would end up with 2r squared is equal to a. So area of the square as a function of radius is a is equal to 2r squared. So then B wants the instantaneous rate of change of the area with respect to the radius. That just means take the derivative. So what is the derivative of 2r squared? 4r. C says,
Does the denominator mean, what does the denominator mean in the derivative?
if the denominator is just a number, then it's just like the number that you're pulling out of the exponent over whatever the denominator is. But a lot of times it'll be something that will cancel or like simplify. Like in the last one, you had c squared over 4 pi or 1 over 4 pi times c squared. So when you took the derivative, you throw the 2 out front, which really puts a 2 on top. So what that really gave us was 2 over 4 pi times c. Well, then that canceled, the 2 and the 4 cancel to give you 1/2 over pi, or over pi times c, or c over 2 pi,
Got it.
like we had there.
Okay, but I mean, like, in the definition, it says d of a over d of r.
Oh, that's just another way to write derivative. So that means we're taking the derivative of area with respect to the radius. That's what this means. So whatever variable's on the bottom is whatever we're actually taking the derivative of. So like when we had like a y equals 3x squared, what we would have written is,
Y.
we either wrote, well, a lot of times we wrote y prime is equal to 6x, but a lot of times the way the book will write it, and we do it this way intentionally because of a section that's coming up, because you're going to want to write it this way. Like you're going to need to write it this way for your, like, the word problems to make sense. So what we would write this as, if we really wanted to do it correctly, is dy dx is equal to 6x. The derivative of y, the function y, with respect to the variable x.
Okay.
And this is also going to come into play because later we're going to do problems that require you to actually take the derivative of x and y. It's called implicit differentiation. So that's another time where you're going to want to write it this way. Sometimes with implicit I will just write it in this form, but with the word problems you're going to want it written like this. Oops. Because of what it's going to be asking you for. So. Alright. So then C says to evaluate the rate of change of A at R is equal to 1 and R is equal to 8. So when R is equal to 1, we have 4 times 1, which is just 4. And when R is equal to 8, you've got 4 times 8, which is 32. And then if R is measured in inches and A is measured in inches squared, what units would be appropriate for dAdr? And that would again just be inches.
What was C asking for?
C just said if R is equal to 1 and R is equal to 8, what is the rate of change of A, essentially? So you just plug it in, yeah.
And then D was asking for the
D
measurement.
said what are the units that it would be in, that dAdr would be. All right, so all right, we'll at least start the next one. We'll see what happens. I don't know if we'll get all the way through it. All right, so 8 says the number of gallons of water in a tank T minutes after the tank has started to drain is Q of T is equal to 200 times 30 minus T, and then all of that squared. How fast is the water running out at the end of 10 minutes, and what is the average rate of change which the water flows out during the first 10 minutes? So, this is where we're going to be using this right here. Okay, this limit as delta t approaches 0 of anywhere we see a t in our function, we're going to put t plus delta t. Okay, and then we're going to go from there. But our delta t in this case is going to be the 10 minutes that it says. So 10 minutes. So I'm going to have the limit as delta t approaches 0 of, okay, on top it's going to be anywhere I see t, I'm putting t plus delta t. So it's going to be 200 times 30. Did you just go to Chick-fil-A?
No, her food is in her car.
Oh, I was like, that was really fast.
I don't speak that much. If they were that fast. Wow.
All right, so 200 times 30 minus, now anywhere I see t, I'm putting, okay, my initial t value is equal to 0, okay?
Yeah, I couldn't.
No.
It was not working.
It's easier for me to figure it out.
So t plus delta t, okay, which this is going to be 0 plus 10, okay, and then that, hold on, that whole piece there is getting squared, okay, from this formula. So right now we've taken care of the first part, minus, now we're putting in t, so 200 times 30 minus, or I think that's actually a delta t that goes in there. Where is it? I think that's actually supposed to be a delta t right there. Hold on a second. I may have that part written wrong, because if not, that's what it's supposed to mean, but. Well, it's supposed to be, the book says f of t, but it's supposed to be 10, so it's whatever number you're dealing with is going there. So minus 10 squared over your delta t. Okay, so then the first part says how fast is the water running out at the end of 10 minutes? So
Oh, because t is 0 because that's the initial time?
yeah.
Got it.
But we had, this is supposed to be f of t, but t is at 10 minutes, so that's why, that's what time we're evaluating for, so that's why we put 10 there. What is happening? Okay, hold on. So then we have, how fast is the water running out at the end of 10 minutes? Oh. Okay, hold on. I'm getting a little, we need this, but I'm getting a little bit ahead of myself. That's why I was like, wait a second, where's this going? All right, so we have 200 times, this is, okay, 30 minus t times 30 minus t is essentially what we have going on here. So then this factors into 200 times 900 minus 30t, so minus 60t plus t squared. So Q of t is equal to, so multiply everything by 200, so 180,000 minus 12,000 t plus 200 t squared. So then how fast is the water running out at the end of 10 minutes? We are going to take the derivative. So Q prime of t is equal to, this part's going away, that's going to 0. That's just minus 12,000 plus, pull the 2 out front, so 400 t. And then now we evaluate this at 10 minutes. So Q prime of 10 is equal to negative 12,000 plus 400 times 10. So that's going to be 4,000. So negative 12,000 plus 4,000 is going to be negative 8,000. Or that it asks how fast it's running out. So it's going out at 8,000. And it told us that it was in gallons and then times in minutes. So that's gallons per minute. Okay, so that would be the answer to part A. Now part B is where we need the stuff that I did up top already. Or that I kind of set up top. So I would have 200 times 30 minus, okay, that's just going to be 10. So 30 minus 10 squared. Minus 200 times 20 squared.
So negative becomes, what's the word,
Also, I have something written wrong in the top. I figured out what I did. I have it written wrong on my paper, that's why. What?
the negative, is it supposed to be negative? I don't understand.
Right here?
Do we disregard?
So the negative here was telling you that it's running out, but since the question said at what rate is it running out,
Oh.
I just said 8,000 gallons per minute.
Got it.
But yeah, I probably should. If it was positive, it would have indicated that it was filling at 8,000 gallons per minute, which would be super impressive.
That would be. It would be running out of negative 8,000 gallons.
Well, the negative, okay, so you have to remember the math doesn't know that the question was what rate is it running out. The question asks you at what rate it's running out, so you can just say 8,000 gallons per minute. But if the question just said, tell me at what rate it's either running out or filling, you would need to specify that because it's negative, it's running out. If it's positive, it's filling. So then this is 200. So this is where I said, earlier I was like, oh, this is supposed to be delta T. It's actually supposed to be T, so this should have been 0. Okay, up here. So I had the wrong thing written there. So this is times 30 squared all over delta T. This is where the delta T goes, which is 10. And so that gives you, I'm just going to run through it really quick, but 20 squared is 400 times 200. So 200 times 400 minus 200 times 900 divided by 10 is equal to, let's see, 8 and 4 zeros. So is that 80,000 minus 18 and 4 zeros divided by 10. So that's negative 100,000 divided by 10. One of the zeros is going to cancel off the top, so that's just going to give me negative 10,000. Okay, which means that for that question it says what is the average rate at which the water flows out during the first 10 minutes? It's 10,000 gallons per minute that it's flowing out.
Can we go to school?
Yeah. Who has donuts for lunch?
Not me.